Your understanding of valence electrons is going to become imperative in chemistry because valence electrons are the electrons that live on the outermost shell of an atom. So think about this. If atoms are moving around in space and they bump into another atom, what part is going to bump into the other atom first? It's the valence electrons. So that's going to determine how they combine with other atoms, or maybe they won't combine, or maybe they'll react, or maybe they'll make something new, or maybe they'll steal, or maybe. So we need to know how many valence electrons they have to start the conversation about how are they going to act when they run into other atoms. Now, there are a couple ways you can determine how many valence electrons an atom has. The first one is to know its position on the periodic table. Now, here's the thing. If you're following along in my lessons, you probably don't know what that trick is yet, because that's actually coming up in the whole next unit of lessons. And if you want to jump ahead, you can go look at those. But I would encourage you to stick here and find out, okay, there is a way to figure out from the periodic table how many valence electrons there are. But there's also a way using electron configuration, which is what we've been learning about in a whole sequence of videos. If you need help with those, go to the description. You'll see all of them listed down there, and you can work your way backwards and catch up with us. Let's work our way through this. We're going to start off with one that's fairly simple. Sodium has 11 electrons. Sodium is right here. Now, the goal is to figure out how many valence electrons it has. In order to do that, we need to know what the electron configuration is for sodium. So I've got 11 electrons. I'm going to come down here and I'm going to start to throw them at my atom and find out where they land. The first two are going to live in the 1s. The next two are going to live in the 2s. I've used a total of 4. The next six can live in the 2p. Now, if I count this up, I used 4 up down here. I just threw 6 more at it and they landed there, which means I only have 1 left and it's going to live right there. I've used a total of 11 electrons. Let's write this out in the order that we drew our lines through. That's called the electron configuration. We have 1s2, 2s2, 2p6, 3s1. Okay, now if I go back to the definition of valence electrons and how I determine them from this, what I'm looking for is the highest energy level. So I have electrons in the first energy level, I have electrons in the second energy level, and I have electrons in the third energy level. Well, my highest energy level is the third energy level right here. And how many electrons are living there? 1. So how many valence electrons does sodium have? It has 1 valence electron. That's how we determine it, using electron configuration. Let's try a couple more. Well, how about phosphorus? Phosphorus is number 15 over here. So it has 15 protons. If it's electrically neutral, it has 15 electrons. If we go ahead and we put them on here and we figure out where all of those live, we're going to keep doing this until we get to 15 electrons. 6 here, 2 more there. That's a total of 8. That means I've used up 12. I'm trying to get to 15. 3 more can go right here. I'm going to write out the electron configuration in the order we filled it up, which is 1s2, 2s2, 2p6. I'm right here, by the way. 3s2 and 3p3. Okay, the goal here is number of valence electrons. If I look, I've got electrons in the first energy level, second energy level, and third energy level. And the third energy level is definitely our highest energy level. How many electrons do we have living there? Well, there's 2 electrons living in the s orbital in the third energy level, and 3 electrons living in the p orbital in the third energy level. So that means we've got a total of 5 valence electrons. Okay, that's good. We can also get that from the noble gas electron configuration. If we look here, we can see that the highest energy level where electrons are living is the third energy level. They're represented outside of the noble gas neon. And we can see there are 5, which is the same answer we got when we wrote out the entire electron configuration. And the best way to learn these is practice, practice, practice. I would encourage you to pause the video, work your way through selenium, then come back here and check your answer. And for those of you not pausing, I'm going to work through it anyway. Selenium right over here has 34 electrons. So how many valence electrons does it have? Let's go. I've used 2. I've used total of 4. This can hold 6. This can hold 2. That was 8 more. I've used 12. The 3p and the 4s. This can hold 6. This can hold 2 more. That's 6, 7, 8 plus the 12 I've already used. I've used up 20, trying to get to 34. This one here will hold 10. So now with the 10 I just put there and the 20 that's there, that's 30, which means I only have 4 to put right here. Okay, and that takes me to 34. Let's write it out. 1s2, 2s2, 2p6, 3s2, 3p6. I'm right here. 4s2, 3d10, 4p4. Now here's the thing. This is where people always make mistakes. We look at this right here. Let me get a different color. And they see, oh, look, there's the 4th energy level. It has 4 electrons. So selenium has 4 valence electrons. No, that would be wrong. Or they say, wait a minute. Is it the 3d10 because that one is the farthest? No, it's not that. We're still looking for the highest energy level. And the highest energy level where electrons live is this 4th energy level right there and right there. Well, why aren't they in order? Because they don't fill up in order. That goes way back to when we learned about where electrons live and why they end up in their various places. And so if I was to write this out in the order of their energy levels, it would look a little different, and maybe it's a little more understandable. 1s2, 2s2, p6, 3s2, p6. Notice I'm just leaving that off. Oh, look, there's one over here. That's d10. Then we have 4s2, p4. Just a different way of writing it. Both of them are completely fine. And if we come back here and look, well, look, we still have a 4th energy level, has a total of 6 valence electrons. So how many valence electrons does selenium have? It has 6 valence electrons. Magnesium, well, let's find it right here. Number 12 on the periodic table. So let's put 12 electrons on our magnesium and find out how many valence electrons it has. 2 will live here. 2 more here. That's a total of 4. 6 can live here. 2 more there. That was 8. I've put a total of 12. Look at there. That's 12. That's exactly what I wanted. So let's write this out. 1s2, 2s2, 2p6. Right here, 3s2. That is the electron configuration for magnesium. And just for practice, because we've been doing this, if we write the noble gas electron configuration, look, there's magnesium. We're going to work our way backwards till we reach a noble gas. 12, 11, 10. Oh, right there is a noble gas. So that noble gas would be 2, 4, 6 more is 10. That would be this right here, which is neon. And 3s2. If we look at this, the highest energy level is the 3rd energy level. It has 2 electrons, so we can figure that out from the complete electron configuration. And also in the noble gas electron configuration, it shows us that magnesium has 2 valence electrons. Practice makes perfect. Just keep working through these and you're going to get really, really good at them. And in some upcoming lectures, I'm going to show you some tricks about the position of these on the periodic table. We'll very quickly tell you how many valence electrons they have. Some quick practice then. We've got whatever element this is. We're not even sure which one it is, but we know if we look, the highest energy level, it has 5 valence electrons because look, 2 plus 3 is 5. And there's 5 electrons there, and this was helium. So helium is right here. It has 2, and 5 more makes 7. Right here, that's nitrogen. So nitrogen has 5 valence electrons. And last one, let's go. We have argon. And then we can see everything that's after the noble gas. The highest energy level is the 4th energy level. So whatever element this is, I don't even know at this point, it has 6 valence electrons. And if we just kind of work our way back through this to find out which actual element it is, we go over here to argon. Argon has 18. And then outside of the argon, we have 10 plus 2 plus 4. That's 6 more. So that's 16 plus the 18 of argon. And 18 plus 16 equals, well, what element are we looking at then? This is selenium. And we know that selenium does have 6 valence electrons. And interestingly, I could have told you that at the very beginning because of selenium's position on the periodic table will tell me that it has 6 valence electrons. That's coming up in a later lesson. Now that we understand the valence electrons, it's important that we're able to diagram those valence electrons. This is just a quick look at taking what we've just done with electron configuration, noble gas electron configuration, and valence electrons, and turning that into something that's useful, like this diagram you see next to me. So stick with me and keep on learning.